Fossil fuels. Fossil fuel is a term used to describe a group of energy sources that were formed from ancient plants and organisms during the Carboniferous period approximately 360 to 286 million years ago, even before the age of dinosaurs. At that time, the land was covered with swamps filled with organisms and plants. As they died, they sank to the bottom of swamps and oceans and over millions of years started decomposing under layers of sand, clay, and other minerals. Different types of fossil fuels formed depending on the combination of organic matter, temperature, time, and pressure conditions while decomposing. There are three major types of fossil fuels: coal, oil, and natural gas. Coal was formed from ferns, plants, and trees, which hardened due to pressure and heat. Oil was formed from small organisms like zooplankton and algae, where pressure caused the more complex organic matter to decompose. Natural gas was formed by the same process as oil, only it was exposed to more heat and pressure, causing it to further decompose and turn into a gaseous form. Fossil fuels are sought-after energy sources because they have a high energy density. They are the world's dominant energy source. Fossil fuels have a variety of applications from electricity production to transport fuels. They can also be used to make a variety of common products, from plastics to cosmetics to even some medicines. These resources have powered industrialization over history and continue to do so today. Fossil fuels can be an abundant and cheap, or in some cases, a scarce and expensive form of energy, depending on geographic location. For this reason, geopolitical issues arise due to scarcity caused by the natural geographic allocation of these highly valuable resources. Fossil fuels are considered non-renewable resources because they take millions of years to form, which means that once they are used, the resources will not be replenished in a human lifetime. The gradual depletion of the most accessible fossil fuel reserves have forced companies to develop technologies for extracting more challenging or unconventional reserves. In many cases, this means additional safety and environmental concerns as well as higher costs. Fossil fuels are also the largest emitters of carbon dioxide, a greenhouse gas which causes climate change. In addition, their production causes both environmental and human health issues. These concerns have triggered society to look at alternate sources of energy that are more environmentally sustainable and renewable. That's fossil fuels.
The area surrounding the North Pole may seem like a frozen and desolate environment where nothing ever changes, but it is actually a complex and finely balanced natural system. And its extreme location makes it vulnerable to feedback processes that can magnify even tiny changes in the atmosphere. In fact, scientists often describe the Arctic as the canary in the coal mine when it comes to predicting the impact of climate change. One major type of climate feedback involves reflectivity. White surfaces like snow and ice are very effective at reflecting the sun's energy back into space, while darker land and water surfaces absorb much more incoming sunlight. When the Arctic warms just a little, some of the snow and ice melts, exposing the ground and ocean underneath. The increased heat absorbed by these surfaces causes even more melting, and so on. And although the current situation in the Arctic follows the warming pattern, the opposite is also possible. A small drop in temperatures would cause more freezing, increasing the amount of reflective snow and ice. This would result in less sunlight being absorbed and lead to a cycle of cooling, as in previous ice ages. Arctic sea ice is also responsible for another feedback mechanism through insulation. By forming a layer on the ocean surface, the ice acts as a buffer between the frigid Arctic air and the relatively warmer water underneath. But when it thins, breaks, or melts in any spot, heat escapes from the ocean, warming the atmosphere and causing more ice to melt in turn. Both of these are examples of positive feedback loops, not because they do something good, but because the initial change is amplified in the same direction. A negative feedback loop, on the other hand, is when the initial change leads to effects that work in the opposite direction. Melting ice also causes a type of negative feedback by releasing moisture into the atmosphere. This increases the amount and thickness of clouds present, which can cool the atmosphere by blocking more sunlight. But this negative feedback loop is short-lived due to the brief Arctic summers. For the rest of the year, when sunlight is scarce, the increased moisture and clouds actually warm the surface by trapping the Earth's heat, turning the feedback loop positive for all but a couple of months. While negative feedback loops encourage stability by pushing a system towards equilibrium, positive feedback loops destabilize it by enabling larger and larger deviations. And the recently increased impact of positive feedbacks may have consequences far beyond the Arctic. On a warming planet, these feedbacks ensure that the North Pole warms at a faster rate than the equator. The reduced temperature differences between the two regions may lead to slower jet stream winds and less linear atmospheric circulation in the middle latitudes, where most of the world's population lives. Many scientists are concerned that shifts in weather patterns will last longer and be more extreme, with short-term fluctuations becoming persistent cold snaps, heat waves, droughts, and floods. So the Arctic's sensitivity doesn't just serve as an early warning alarm for climate change for the rest of the planet. Its feedback loops can affect us in much more direct and immediate ways. As climate scientists often warn, what happens in the Arctic doesn't always stay in the Arctic.
So, what do you think of the videos?
Well, clearly they address how fossil fuels forms and how it affects the planet. But I guess it's also better to add some more solutions and also say the political side of the conversation.
You know, fossil fuels are used to fuel cars and airplanes, power electricity plants, and heat our homes. They are also used to make medications, cosmetic, plastic, synthetic fabrics, and lubricants. When you brush your teeth today, you should use a product made from oil, toothpaste. Look at your shoes. They are a product made from oil. Sunglasses, tires, tennis balls, and TVs are all products of oil and gas. Next time you're playing basketball with your friends, think about the ball you're dribbling. You guessed the rubber to make all the ball came from oil. The fact is, a huge number of products that we're used every day wouldn't be available without oil and gas, extracted and processed.
You know, that's impressive, but still, fossil fuels are bad. I mean, it's a fuel that is formed from the earth of dead planets and animals. Our planet is wrapped in a layer of greenhouse gases. This layer acts like a blanket, keeping the earth warm and shielding it from the cold of the universe. This is commonly referred as to greenhouse effect. Carbon dioxide, CO2, while not the most potent greenhouse gas, is nevertheless the main driver of the greenhouse effect. When fossil fuels, coal, oil, and natural gas are burned, they release CO2 in the atmosphere. Because of this layer of greenhouse gases getting thicker, which is in turn making the earth warmer, thus, the ongoing unlimited burning of fossil fuels is the cause of climate change.
As you know, when a climate changes, disastrous things happen, as you saw from the video. Did you know that if we burn all of the remaining fossil fuels on Earth, almost all of the ice in Antarctica will melt, potentially causing sea levels to rise by as much as 200 feet, enough to drown most major cities in the world?
But you know, we can change that. In fact, we can use alternate source of energy, such as solar power. The sun's energy exploited by solar panels, collectors or cells to heat water or air to generate electricity.
Wind energy, power derived from wind, used to generate electricity or mechanical power.
Also hydroelectric power, a form of energy generated by the conversion of free-falling water to electricity. The generation of electricity by using the motive power of water, also called hydroelectricity.
Geothermal power, power generated using steam produced by heat emanating from the molten core of the Earth.
And also nuclear power, which is kind of dangerous. It's the source which comes from nuclear fission.
And from the world of politics. Politics involves making decisions that govern other people's lives, and critical to base these decisions on solid information. One well-known politician leads the pack of those who make human-caused global warming their rallying cry, former U.S. Vice President Al Gore. He was spent the last 15 years sounding the alarm. His documentary, filmed An Inconvenient Truth, 2006, won an Academy Award, and in 2007 he was awarded the Nobel Peace Prize for his efforts.
You know, Gore believes his cause is so important that overrepresentation of the fact is justified. He said nobody is interested in solutions if they don't think there's a problem. Given that starting point, I believe it's appropriate to have an overrepresentation of factual presentations on how dangerous it is, as a predict for opening up the audience to listen to what the solutions are.
The public appears to be growing less concerned about the seriousness of global warming, in part because temperatures have declined over the last decade, and because the dissenting scientific view has achieved more widespread awareness. According to Gallup Poll of Americas in March 2010, for example, 48% of Americans now believe that the seriousness of global warming is generally exaggerated, up from 41% in 2009, and 31% in 1997 when Gallup first asked the question.
Where also EPA, United States Environmental Protection Agency, is taking a number of common sense steps to address the challenge of climate change, such as collecting emission data. EPA collects various types of greenhouse gas emission data.
Getting reductions, EPA is reducing greenhouse gas emissions and promoting a clean energy economy through highly successful partnerships and common sense regulatory initiatives.
So overall, if you can't switch or use alternate source of energy, then do the simplest thing. Plant a plant. And thank you.
Final, bitches.